Okay, today we're going to start Unit 4 and look at what's called basic identity. So we want you to be able to show that some trig stuff equals other stuff using some of the equivalencies that we know with trig. The first one we're going to look at that you've seen a little bit before is the Pythagorean identity, meaning if you take the sine squared value plus the cosine squared value, it equals 1 from the unit circle, because we know on the unit circle, uh, the radius of any place here is 1, and you're going to get some x, y point here because you got a x value and a y value. So on this, using Pythagorean theorem with this right triangle, x squared plus y squared equals 1. We know that in unit circle, the x value comes from cosine, so that means it's cosine of the angle squared plus y is the sine value, so sine of the angle squared equals 1. And that's where we come up with this. Now, as you can see on this one, these little 2's here are placed in between where it says cosine and the angle. That's just notation that tells you that this really means sine of the angle squared and cosine of the angle squared. But because people in math didn't want to have to write those parentheses all the time, they came up with the notation of putting the squared there to mean that it's being squared. Okay, so an example, if you did it at pi, where theta equals pi over 6, that would produce these 2 points, because from unit circle, or you could use your calculator at pi over 6, right here, which is also 30 degrees, you get the ordered pair from the special right triangle of square root of 3 over 2 and 1/2. So just to show you that this does work, remember you can put those in for the x and y value then, and this should come out to equal 1. So if we did square root of 3 over 2 squared plus 1/2 squared, that should equal 1. If we square both the top and bottom here, square root of 3 squared would just be 3. 2 squared would be 4. And the second one, the top 1 squared is 1. 2 squared is 4. If we add up 3/4 and 1/4, we do get 4/4, which does equal 1. So it shows that it does work. You should know the Pythagorean theorem one. We also know some of these reciprocal values. Cosecant is the same as 1 over sine. Secant's the same as 1 over cosine. Tangent, sine over cosine, and then cotangent's 1 over tangent, so that would be the reciprocal of cosine over sine. So those are also going to be important as we start looking at these identities. Using what we know then, that Pythagorean identity of sine squared plus cosine squared equals 1 could also be written differently just by moving stuff around. So sine squared, if we would subtract cosine, would be the same as 1 minus cosine squared of the angle. If we did the same thing and solve for cosine squared, it would be 1 minus sine squared. We can also come up with some other identities off of this by dividing by either sine or cosine. So if we took this identity right here of sine squared x plus cosine squared x equals 1, and we went through and divided everything by sine squared, we'd get a new identity. And it would be the one listed here. Sine squared divided by sine squared would be 1. Cosine squared over sine squared. Cosine over sine is the same as cotangent squared. And then 1 over sine squared is the same as cosecant squared. And so we get this identity right here if we minus cotangent to the other side. And so this identity right here comes from the Pythagorean one just by dividing everything by sine squared. So using that, cosecant squared you can see is equal to 1 plus cotangent squared. If we would solve this for the other variable, solve it for cotangent by minusing 1, cotangent squared would equal cosecant squared x minus 1. All right, similar, we can come up with one more identity off of this one. If we would take it and instead of dividing by sine squared, divide everything by cosine squared, we come up with a third identity off of this Pythagorean theorem one. So let's divide everything by cosine squared this time. And what we get then is sine over cosine is the same as tangent squared. Cosine squared over cosine squared, that's 1. And 1 over cosine squared, that's secant squared. And so what we come up with if we would get everything on the same side is this one, which says secant squared minus tangent squared equals 1. And so secant squared, solving this from what we see here, would be the same as tangent squared plus 1. And if we would solve it for the tangent, it would be secant squared minus 1. So these identities can also be used to help us solve when we're doing, when we start getting into some of these problems where they're going to ask us to show stuff. So sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant squared. So that we can use to help us out. All right, also some things that you're going to want to do when proving these identities is pick a side of the equation to work with and then kind of solve it for the other one. Look for algebraic things to do. So if you have two terms and you want to into one, add the fractions to get a common denominator, maybe try to factor something out. If you sometimes you might want to multiply by like a conjugate. Do any obvious algebra like distributing or squaring or multiplying. Some other stuff to do. Look for some of those reciprocal functions or the Pythagorean one, and then at the end try to reduce and make things look the same. The big thing in these is a lot of times it's just trying to get stuff in terms of sine and cosine. And so this first example, we want to show that what's on the left here equals what's on the right. So first thing that usually is easiest to do, write things in terms of sine and cosine. So let's do that first. This is already a cosine, so let's not mess with that. Secant. We know secant's the same as 1 over cosine. All right. So now we've written everything in terms of sine and cosine. Next, let's try to do any math stuff we know. Well, we see parentheses. What do we usually do with parentheses here? Distribute. So let's distribute. So if we distributed this, this would be cosine over cosine minus cosine times cosine would be cosine squared. Well, what's cosine divided by cosine? That would be 1 minus cosine squared. And what does 1 minus cosine squared equal? That does equal, using our Pythagorean theorem identity, sine squared plus cosine squared, we know equals 1. So what is, if we minus that cosine to the other side, what's that equal to? Sine squared. So this would be equal to sine squared. And now what we've shown is that sine squared is equal to sine squared, showing this identity. So both sides now come out to be equivalent. So when you're doing these ones, you want to show that both sides are equal. So this whole time, since we had this equal to sine squared, now we finally showed that it is equivalent. All right, let's try another one. Verify this one. So again, we want to show that the left side equals 1. So let's first do like we did on last one. Let's put this in terms of sine and cosine. So sine is already 1. Secant we know is the same as 1 over cosine. And then tangent's the same as sine over cosine. we want to show that equals 1. So next, let's combine the top into one fraction. That'd be sine x over cosine x all over sine x over cosine x. Well, what happens if you got the same thing over the same thing in math? It always divides to equal 1. So we've shown now that 1 equals 1. And we've proved that both sides are equal. All right, let's try another one. They want us to verify this one. Okay, so again, try to get everything in terms of sine and cosine here. This one, actually, we could probably maybe look at doing another way. If we got two things on top here and one on bottom, let's maybe try to split this into two fractions. So we got secant squared x over that common denominator minus 1 over secant squared x. And we want to show that equals sine x. Well, what do you get when you have the same thing over the same thing? That would be 1. 1 over secant squared is the same as cosine, so this would be the same as cosine squared x, because remember, cosine x equals 1 over secant x, so that would also mean that this is equal to cosine squared. All right, well now we want to show this is equal to cosine x. Well, remember, anytime you're dealing with 1 and cosecant x, that looks again like our Pythagorean theorem one. Cosine squared plus sine squared equals 1. So if we minus cosine, what's sine squared going to be equal to? 1 minus cosine squared. And so we can replace all this with sine squared x. And now we've shown that both sides are equal to each other. All right, your turn. Why don't you pause the video and try this one out. Again, kind of think back. A lot of times it's best if you can write the things in terms of sine and cosine. All right, let's see what you came up with. Sine, that's already sine, so let's not mess with that one. That's already cosine, let's not mess with that. Cotangent we know is the same as cosine over sine. And we want to show this is equal to cosecant. All right, well, what do we do on this one? Well, let's combine the stuff we got here. That's sine theta plus cosine times cosine would be cosine squared theta over sine theta. All right, what can we do here now? Well, we got to go two things down to 1, so it'd probably be best if we combine this into one fraction. But the only way to do that is to multiply this one by and get a common denominator of sine, but that means the top we're also going to have to multiply by sine. So if we do that on this one, we'd have sine times sine is sine squared plus cosine squared all over now a common denominator of sine, because both of these should have the same denominator now. All right, and again, we want to show this equals to cosecant x, or cosecant theta, I guess. All right, well, what do we know about this? Sine squared plus cosine squared, that's that Pythagorean one. That's the same as 1. So now we got 1 over sine theta equals cosecant theta. And what do we know about that? 1 over sine is equal to cosecant. And so now we've shown that cosecant equals cosecant. So that would be showing both sides are equal. All right, you're going to try some of these out now. So see if you can try these ones out of the book, 25 through 31, and show that both sides are equal using some of these trig identities.